Hello everybody, this is Solar Tiger, and today is Sunday the 27th of September, and this is another video on my solar power system. Outside you can see the sun is shining and there's no wind. So outside are the two 100 watt monocrystalline solar panels. They are wired in series to give a nominal 24 volts, although in sunny weather the voltage can go up to the low 40s volts. So there are the solar panels outside on the solar panel stand. Now if I bring you inside, you will see that I have made a change to my battery box system. So I used to have three 12-volt batteries that were wired in parallel to give 12 volts at 300 amp hours. Now I have bought another battery. I have 4 batteries now. I got a good deal on another 12-volt battery. So as you can see in the battery box, there are 4 batteries, and they are now wired in series parallel to give 24 volts. That's right, I have now changed over to a 24 volt system. If we have a closer look at the batteries, okay, these are 12 volt 100 amp hour batteries. They are sealed AGM batteries. These are recommended for indoor use as they do not vent off any gases under normal conditions. Now you'll see that I have the batteries wired in series. So in a series connection, the batteries are connected together. So we have plus of the first battery and the minus. Now the minus is connected to the plus of the second battery, and that means the voltages add together. So 12 volts plus 12 volts equals 24 volts, and I have 2 lots of batteries wired in parallel. So plus to plus of the first battery and minus to minus of the second battery. So we have a total capacity of 24 volts at 200 amp hours. So in series, the voltage of the batteries adds together, and in parallel, the amp hour ratings of the batteries add together. So we have a total of 12 volts. We have 24 volts rather at 200 amp hours. Now, I used to have a 12 volt system, and all my load devices are 12 volts, such as the lights, fans, the USB chargers, etc., all run on 12 volts. So I cannot connect the 12 volt devices directly to the 24 volt battery bank. So I could go and buy a whole load of new 24 volt devices, but why should I do that when I have perfectly good 12 volt devices? So the way around that is to use a voltage converter. So the 24 volts from the batteries goes to the charge controller, to the load output. Now from the load output I go to the voltage reducer. Now these things have different names, but they're sometimes called voltage reducers, voltage converters, voltage droppers, DC to DC converters, but they all do the same job. In this case, it takes 24 volts on the red and black wires and convert it down to 12 volts, and it comes out of the yellow and black wires. And the yellow and black wires simply go to the distribution board. So it is kind of like a DC transformer. it converts the 24 volts from the batteries down to 12 volts for my load devices. So this converter is rated at a maximum of 10 amps. So that's okay. So that's how that works. Now the charging system is exactly the same as before. We have the solar panels outside that feed in to the charge controller, and the charge controller charges up the batteries. Now this charge controller can be used on a 12 volt or 24 volt system. The controller detects the battery voltage when it first is powered on. So that's why you must connect the charge controller to the batteries first so that it can make the correct selection, and only then should you connect the solar panels. So that's how that works. Now this SunSaver MPPT is a 15 amp controller, and with a 12 volt system it can handle 200 watts of solar panels, and on a 24 volt system it can handle 400 watts of solar panels. So I could now, in theory, add another 200 watts of solar panels. Now the weather outside is sunny. It's about 20 past 10 in the morning, and you can see that we are bringing in a massive 9.2 watts. That's 0.26 amps at a voltage of 35.49 volts. We've produced 16 watt hours so far, and 0.477 amp hours. So that's how my system is. You will note at the moment that I don't have a inverter, because I am having to buy a new inverter that works on 24 volts. Now you may ask, why have I gone to a 24 volt system? Well, the answer to that is I want to buy a bigger inverter. The inverter I had before was only 300 watts, so I want to buy a 1000 watt inverter. And the reason I went to a 24 volt system is that to produce 1000 watts at 24 volts I need approximately 40 amps, but to produce 1000 watts at 12 volts I would need 80 amps. Now you'll know that a cable to carry 80 amps is thicker and is more expensive than a cable to carry 40 amps, which will be cheaper and thinner, so easier to handle, but also lower currents are much safer. Higher currents are a bigger risk of fire, and we don't want that. So I am looking to buy a 1000 watt inverter or something similar, and I need to get a 24 volt inverter. It means I can run bigger appliances. Namely, I would like to be able to use a vacuum cleaner in this room, and I have an energy efficient Dyson vacuum cleaner which uses 650 watts, so I will be able to run that. So that's why I'm going to buy a 1000 watt inverter, and at 24 volts it will use much less current than on 12 volts. So that's how my system is. So I will have to buy a new inverter. This inverter is a 12 volt inverter, and it won't work on a 24 volt system. I will also have to do something with the wind turbine, because it's only a 12 volt wind turbine, and 12 volts trying to charge a 24 volt battery bank is not going to work. So I will have to connect a DC to DC converter to the windmill, which is to do with that wiring down there, but that's another thing for another day. Now I come to the meter that was on my desk. Now this meter used to measure the voltage of the batteries, but now it only measures the voltage output of the DC to DC voltage converter, and it is a 12-volt voltage converter. It takes the 24 volts rather from the battery bank and outputs 12 volts, or just a little bit over. So this does not actually show you the voltage of the batteries. I will have to do some modification here. I will either have to buy another meter or modify this one so I can connect it across the battery bank. So the actual voltage of the battery bank at the moment is 25.76 volts. Says we're not actually charging the batteries at the moment, but it's still early days yet. Anyhow, last night the batteries went down to 25.57 volts. At the moment we are not using any current. The indoor temperature is 21 degrees Celsius. And the solar panel voltage is 35.25 volts. So that's that. So we are now on a 24 volt system, and it's going okay. So I will need to buy an inverter and wire that up, because at the moment I'm having to plug things into the wall socket again, and that's not good. Elsewhere, the power box is working fine, and the lanterns. In fact, I was using this power box because before, well, a couple of days ago, I had the batteries wired up, but I didn't have this voltage converter, which means I couldn't connect my DC loads to the battery bank. So I was charging my USB devices with the power box. I was thankful for having the power box. So this is Solar Tiger saying thank you for watching, and just to recap, I have now gone to a 24 volt battery bank, and this is how it is. So I'd like to say thank you for watching, and until next time, thank you.